So I'm taking over from her to introduce our keynote speaker, Somayeh Dodge. Somayeh has a degree in engineering. She's actually a typical GI scientist, I think, because she's been going back and forth between topics while keeping to her own topic at the same time. So she started off with engineering. She's coming from Iran. In 2008, I think you did your master's. The master's? Oh, well, okay, whatever. Just doesn't matter. Long ago. But then she switched to geography, and she did her PhD at the University of Zurich in 2011, because I got that written down. Then she also continued on to the moving years, which is something that's very, very important in science. You don't just do your PhD, that's basically the entry door, but then you also go to different places, learn different methodologies, different people, build your own network. And you did that, Somayeh, by going first to Ohio State, back to the engineers, right? Then continued on to Minnesota and to University of Colorado, each 3 years. And I think in Minnesota, you already were assistant professor. Assistant professor, exactly. Since 2019, she's now just before the the crisis, like Corona crisis, she's now at UCSB, University California, Santa Barbara, in the geography department, back to the geographers, which I quite like. So you basically settled down now as an associate professor and hopefully soon to be a full professor as well. Your main topic has always been movement. And I think moving years also reflect that to a certain extent. Movement, analysis of movement, visualization of movement, spatiotemporal pattern detection of humans, but also of animals. That's your main topic. And that's also why she heads the MOVE lab at UCSB with currently, I think, 7 PhD students, something like that. So a big group, quite a lot of potential for changing the world in that sense. You have also received 2 awards, won the NSF Career Award in 2021 and an Early Scholar Award from the Association of American Geographers in 2022. Early career, I think you're not that early anymore. You're quite settled right now. And I'm very much looking forward to your presentation, which is, I didn't write down the title, sorry. I thought it was, and you changed the title. Okay, yeah, movement even in other ways. Okay, thank you very much. Looking forward to your presentation.
Yeah, thank you. Again, thank you for being here. And well, AGILE is very special to me. AGILE, in fact, was my first conference that I attended as a PhD student back in 2008. And back then, Gennady and Natalia Adrienko, who are not here today, organized a workshop on agile visualization of dynamics, movement, and change. And that was the first time that I presented as a PhD student. And that started my whole journey of, being a scholar, publishing, and presenting conferences. And from that workshop, they organized a special issue that my very first PhD paper appeared in that special issue. And to this day, is still my mostly cited paper. So to all PhD students there, so take advantage of this opportunity and enjoy AGILE and try to make new connections and collaborate. So today's AGILE theme, very timely, is on GI science for a sustainable future. And therefore, I thought it would be helpful for us to start with the UN Sustainable Development Goals of 2030, that with the aim of achieving a better and more sustainable future for everyone. So these goals were developed by the UN to basically there are 17 different goals to, for example, reduce poverty, reach zero hunger, or protecting our land, our water, our sea, and also make climate action to protect biodiversity and human life, and enhancing human well-being and health on the planet and for urban areas. Also for in creating more sustainable and resilient cities. So throughout the conference, over the next couple of days, I hope you engage in this conversation and think about how we as GI scientists, we can contribute to these goals. In order to understand how to contribute to these goals and how to achieve these goals, Dr. Jeffrey Sachs, in his book of the Age of Sustainable Development, which I highly recommend you all read this book. It's a very enlightening book. He lays out a framework that has 3 dimensions that in order to reach our sustainable goals, he suggests that we need to reach economic growth, but also at the same time, we need to enhance our social inclusion and health and well-being of people, but also protect our physical environment and the earth to be able to reach a sustainable future for everyone. Today, I focus mainly on movement and mobility because that's the area that I work in, and I try to describe different ways in which GI scientists can contribute to sustainable development goals based on data, spatial and spatial temporal data analytics. Okay, again. Okay. So we all know that movement is a mean for us to access resources, to engage in activities, to reach to different locations for different variety of purposes, and also movement causes us to be exposed to the environment and interact with the environment, and therefore anything that is happening in the environment, we might get impacted through our move or exposed to through our movement. Therefore, we can use movement maybe as a signal, as a indicator of behavior to measure not only behavior and behavioral changes as a response to environmental variability, but also understand human and animals' exposure to environmental hazards or responses to, for example, in terms of what we had during the COVID medication of COVID, it will basically increased reduced our mobility because we needed to stay at home to reduce the chances of getting COVID. So throughout this presentation, I will give some of the example of my work, but before that, I wanted to share these 2 papers with you. So in 2020, we asked our editorial board of the Journal of Spatial Information Science to contribute vision papers that lay a vision for the future of GI science. Drs. Harvey Miller and Martin Lavelle contributed these 2 pieces that lays out and describe the importance of movement analytics, but also spatial data science to contribute to a sustainable mobility and sustainable future. So with these 2 papers, they basically argue that mobility is an important piece of urbanity. However, we need to reduce our unsustainable forms of mobility and increase and enhance equality for mobility. So by reducing inequality in accessibility to resources. They basically see our field as a place for making innovation and creating new methods to not only forecast traffic patterns and also understand how we can build a more resilient society, but also to contribute decision-making, better decision-making for urban planning. So our field has generated a lot of tools and methods, but also has more room to be more creative and create new tools for contributing to these goals and sustainable societies. So in the next few slides, I'm just showcasing some of the studies that have been done in this area involving movement and contributing to the Sustainable Development Goals. The first study that I would like to highlight is the study by Dr. Robert Weibel and his colleague, Dr. Christina Rocchi at the Healthy Aging Center of the University of Zurich. So this study is a longitudinal study that aims at understanding how people actually can achieve healthy aging in senior adults by tracking them over a long period of time. So the study has two phases, a few years back, and now again, the tracking started again. And the goal is basically to understand and identify the physical activity profile of adults and connect that with their psychological and with health indicators to understand how their movement activity, their movement patterns, and utilization of active transportation contributes their health and well-being. So they collect tracking data, but also at the same time they collect information about their emotional state and psychological state and intersect to contextualize their movement pattern. The next study that contributes to climate action and protection of our land and biodiversity that I would like to highlight here is the study by different groups, including MoveBank. MoveBank is a global repository of animal tracking data. A lot of biologists and ecologists who collect animal tracking data contribute to MoveBank repository to engage in collaboration in research on understanding animal behavior and space usage. The Biologging Society was a society that started an initiative after COVID happened to connect and intersect cell phone traces data indicating of human behavior and human activity with animal tracking data on the top, indicating animal behavior. So by intersecting the two, they wanted to see how our reduced mobility impacted animal activity. And they showed actually that COVID-19 pandemic created a natural experiment for us to explore the connections between the two. And by that study, they showed that in places that we see a reduced activity in human mobility, we see an uptake of animal activity, and animals were more active in those areas. So studies like that, there have been a lot of studies since then exploring the connections between animal and human intersection and understanding how we impact each other. And finally, the study by that I would like to showcase here is by my dear colleague, Dr. Teresa Lynn Nelson, who is creating a data infrastructure for supporting sustainable and active transportation networks. So she is creating a data infrastructure that incorporates crowdsourced data as well as more authoritative and spatial data to understand accessibility for all, including disabled people and also people who want to walk or bike, and also create a system that we can explore how we can make our active transportation more safe and resilient. And finally, with the increase in access to tracking data, we have been able to explore, better explore the structure of neighborhoods and how places that people do their activities, how that is connected to social interaction and social behavior. And a lot of studies has been done on looking at neighborhood structures and disparity in, for example, the impact of COVID-19 mitigation plans on different neighborhoods and different population segments, and also, for example, how income and physical distancing were connected in terms of how people that were in lower income neighborhood were not have the chances that other people in higher income neighborhood had to engage in basically stay-at-home orders or follow the stay-at-home orders. So here in the now I would like to share some of my work that we did in our group in terms of understanding social inclusion and social interaction, and how people have basically chances or opportunities for social mixing in their daily life. So the study of segregation and social interaction or diversity has long been important in urban planning for basically to contribute to planning of education, employment, and also distributing resources. Here, we wanted to understand not only by the structure of neighborhood and diversity of the neighborhoods, can we use human movement data, mobility data, to better understand the social mixing and diversity of or opportunity for social mixing through daily activities. So we all know in geography that Hagerson created this conceptual framework of a space-time representation of movement that basically connects the anchor point that we do our activities through a space and time. So for example, if you leave from home and go to drop off your kid at school and then go to work and back to go to a market or back to home, then the trajectory, this trajectory or the space-time path of you can be modeled by these 3D space-time cube that represent the anchor point that you conduct the activities and the link between them that connects these activity spaces. So if we intersect the trajectories of people and try to find connections where they intersect, we can identify places that they can interact and maybe have opportunities for social mixing, but also we could identify areas that our trajectories intersect with environmental hazards and the impact on our mobility, study the impact on our mobility. So therefore, we wanted to use movement to study places of activities and how our places of activity creates opportunities for us for social mixing. In this case study, we used LA County, Los Angeles County, which is a very large county and very diverse and segregated, I must say, that has about 9.7 million population, with the majority of population being Latino, followed by whites, and then Asian, and then Black. And as you can see in this map, which is based on residential diversity and segregation, Latinos are mainly dominated in the central LA, downtown LA, and then places that are shaded in orange and light orange shade are white groups. So places that are near to coastal areas are dominated by white population. So these are based on where people live. And we were interested in the question whether we can use the trajectories of people based on where they come from and they visit LA, or well, they are residing in LA, but where do they go to engage in activity and intersect with places of interest such as coffee shops, restaurants, and where do they they conduct activities and meet other people. So, and how that contributes to the diversity that they are exposed and experiencing. So we are using cell phone tracking data from Spectus company, which provides high resolution cell phone traces that are collected from different apps and mobile devices. And the study timeline is March 2019 because it's a normal month without any really major holiday. And also it was before COVID. So what we wanted to do, first of all, we wanted to understand who these people are, because these are anonymized data. So we wanted to estimate the race of these individuals. So first we identified the location of their home based on not only the exact location, but the CBG, which is census block group level for the census, US Census, that is usually used for population studies. So we estimated their census block group, and then based on the composition of the census block groups, we estimated the race of these individuals. So for example, if a census block group is 60% white, 40% Latino, we estimated that the probability of the person being white is 0.6, and the probability of the person being Latino would be 0.4. And then we identify the stop locations of the places of the activities. Where do people stop for a duration? And then we intersected those with places of interest, or POIs, that we had in the database. And these places of interest are, which is about 3 million of visit records, are to coffee shops, restaurants, retails, banks, gyms, and fitness centers, and etc. So then we characterize these places of interest based on their diversity, and for that we are using the scale entropy index, which basically quantify the variation of a variable, which here is race, in a spatial unit. However, we incorporated time into this measure to make it more dynamic. So create a dynamic measure of place-based racial diversity by incorporating time to understand where people actually intersect at the same time. So with that, we consider various groups, various types of points of interest. Low diversity places are those that one group dominates 85% of the population. High diversity is the type that there is no dominance of the group of population, like all population are represented 40%. And then in between, we have moderate diversity group. And then based on who is the dominant group, like Latino or white, or Black or Asian, we consider 13 different unique types for these points of interest. So there's a lot going on this map, so I try to explain. So at the bottom, you see the residential map, the map of residential diversity, meaning that computing the entropy index based on places of residence or the census blocks. And on here, you see the same index, the dynamic index, based on movement to places of interest. So as you can see, overall, the conclusion is that the residential and point of interest data overlap pretty well, like the spatial distribution of them are pretty similar, meaning that people tend to stay in their own communities or visit locations of interest or points of interest closer to their home. And then, however, if you look closely, the points that are characterized as higher diversity points are spread more, and there are more points of interest that are higher diversity, and that indicates that our movement contributes to opportunities for social mixing and enhancing the diversity of these places. And we did apply the clustering to understand where are those locations that are higher diversity, high values, higher diversity values clustered with higher diversity values versus lower diversity values or entropy values clustered with lower entropy values. And as you can see, for the low clusters, again, we see a dominant of Latino group, which may indicate that this group have a stronger social ties with their own community, so they utilize businesses that are majority Latinos, or it might indicate social isolation and segregation of these places that Latino population utilizes. Looking at spatial and temporal patterns. So this one indicates the temporal and this one is spatial. For the temporal, we have different types, the eating places, fitness places at the bottom, I believe, and in the middle, we have grocery stores. So at the left side of this, we have the entropy index for the residential entropy index for the CBGs of these points of interest where they are located. On the right side, you see how visitors increase their entropy index, meaning that based on movement, based on who comes, the entropy increases. So throughout time, especially around noon time, we see an increase of entropy index, meaning that by people moving throughout the city and visiting this location, they enhance their entropy index, they increase their entropy index. Although this increase, again, is not as much for the purple, dark purple, the dominant group for Latino population. If you look at the distributions on the left side, basically you would see two distributions for each types of places. The black represent the residential entropy, meaning that the location where these POIs are, and the gray represent the contribution of visitors to the entropy. So, and looking at the, comparing the two, there is an increase in mean value of entropy index by visitors, based on visitors. So for example, if you look at construction, we can see that the distribution has shifted. So the location of this construction are in the areas that are more of a low diversity. And then based on who goes to this construction site, the diversity increases, right? So the next study that we are doing in our group is on understanding the vulnerability of road networks to contribute to planning of city resiliency plans in California. So basically the idea is, can we use cell phone traces and movement data to understand how roads are utilized during an environmental disruption such as wildfires. So in California, wildfires and mudslides and flooding are issues in terms of environmental hazards that we deal with, and then therefore, it is important to understand how these hazards impact our mobility and road network. So here we are. This is an ongoing study. In terms of road network vulnerability, we are looking at centrality measures to understand our integrity and connectivity of networks. So there are different centrality measures that quantify network as the important elements of the network. For example, degree centrality quantifies the number of connections each element has, or the closeness centrality basically quantifies the elements that are closer to different parts of the network, and betweenness centrality basically quantifies the total number of the shortest path that connects the elements. So if one element is located in the higher number of shortest paths, then therefore that is the most important element. And if that is removed from the network, the integrity of the network and connectivity of the network is disrupted most, right? So the existing work is on mainly using the spatial configuration and topology of the network. Here we wanted to advance that by looking at cell phone traces and understanding actually not only the spatial configuration and topology, but how many trajectories or how many people are actually using these network elements. So we modified the betweenness centrality measure by modifying the shortest path calculation based on the inverse density of these network elements. So for example, how many cars are in each segment of the road to advance the centrality measure. So just an example, we are looking at the Santa Barbara County, the network of Santa Barbara County that connects different cities such as so we have Santa Maria, Lompoc, Santa Ynez, that these areas service to Santa Barbara County. So the connectivity of this network is very important for commuting patterns that happens. So we had a wildfire, Cape wildfire, on the 25th of November, 2019, as you can see, or maybe here. So we are using the tracking data of 1 month of November to understand the changes in patterns of mobility and responses to that wildfire, but also the connectivity of the network. So here we are looking at a calculation of centrality based on the static network and mainly topology versus the dynamic network by applying mobility data. So the blue parts indicates underutilization, meaning that those links, although they were very central to the network, the connectivity of network, they were not used as much when the wildfire happened. And then the reds indicate those links that were overutilized, meaning that although they were not as important in the centrality of the spatial network, however, people chose or used those more, and they became more central to the dynamic network. So we are still exploring what this means, but and understanding what different types of road contribute to that choices. However, this decision can also understanding what roads are more central and what roads are more important when something like that happens. It's helpful for planning purposes. The final study that I showcase is the contributing to more conservation planning that is occurring in Thailand. Thailand is a key area for tigers as keystone species. So Thailand has about 25% of its land on the forest area, and 16% of it is protected. So the government is doing a fantastic job by creating this protected forest area to protect these keystone species and understand their behavior and try to create plans for enhancing biodiversity. So in a collaboration with Dr. David Smith at the University of Minnesota and Dr. Sean Ahern, we are looking at using tracking data of tigers to understand their behavior, their space utilization, but also their interaction with themselves and the other species in that area. So the tracking has been ongoing for around 15 years or even more. So we have a wealth of information about tiger movement and behavior, and we are trying to understand these interactions that are happening in that ecosystem. So tigers are territorial and solitary animals, so they protect their home ranges. Here, the visualization is a collaboration with Esri that we are rethinking how we can map spatiotemporal patterns in 3D and dynamically. So here you're looking at interaction between two tigers, and as I said, tigers are territorial, and how they interact is based on vocal noises and also based on scent marking. So they mark their territory to basically protect their home ranges and expand their home ranges. So what you're looking at here in this animation, you're looking at tracking data of two tigers and the space cube representation. So as you can see, they often interact at the same time, marking their territories, but also they heavily protect that side of the boundary, as you can see in this animation. This is one of the tigers protecting one side of the boundary heavily and at higher frequencies. And that indicates that there is another tiger over there that, in fact, I think the other tiger, we believe that it's her daughter. So that's why they share some parts of their boundary, but still they are protecting their own home ranges. So we are exploring not only concurrent interaction between tigers and leopards, but also their delayed interaction. Here you are looking at animation of tracking data of a female tiger with two of her cubs. As you can see at the beginning, the tiger, the mother walks with her cubs, so you barely see the green and blue lines. You mainly see the red, which is the mother. And then, as you can see here, the distances are lower. Over time, the distances between the mother and the cubs increases, meaning that they interact less and they disperse to find their own territories, the little ones. And so when the animation moves forward, you see the dispersal of the green and the blue cubs to two different areas to explore new areas. And these are the home ranges of the same tigers, and the purple represent the home range of the nearby male tiger. So the male tiger mainly interacts with the mother, and then so the interaction increases when the cubs start to disperse. As soon as the cubs start to disperse, the male tiger comes to the territory and interact with the mother, and then they have another litter there. So by looking at movement patterns and quantifying the interactions between these different animals, we can understand how they interact, how they utilize the space, and how they survive in their landscape, in their ecosystem. So here the cubs dispersed. And that's where the male tiger comes into the territory. Okay, I showed different studies that showcase how we can utilize big data and animal tracking data, human tracking data to understand behavior and interaction with the environment. However, there are some challenges with data sets and that we need to make consideration and plan for how to enhance our analytical results and the utilization of these data sets. So the first thing is representation of cell phone traces. Cell phone traces data have been used a lot in advancing our tools and methods, but also understanding behavior. However, we need to be mindful about how representative these data are and what are the biases in our data set. So here we show during the COVID-19 pandemic, a lot of people started using cell phone tracking data obtained from different companies to model the impact of COVID or the contribution of mobility to a spread of COVID. So what we are showing here, we are showing the data sets that were giving us information about the number of devices seen in the data and correlating it with the population. As you can see here, in the large metro area, we have an underrepresentation in the cell phone traces. So the points that are under this line, like Los Angeles and Chicago and Houston, we see an underrepresentation. So we need to explore that. What is the population that is not represented in the data? And we also need to be mindful about how we are using this data set from these companies. The other problem with this data, the mobility data, is missing data. Oftentimes, when we are exploring the impact of environmental hazards, these are happening in areas with lower density population, for example, in rural areas or in remote areas. For example, here you are looking at the lake fire in LA County, and so the places that that's in the forested area. So some of the places that are lower population that are removed from the data set to protect the privacy of those population, and therefore they are not included in the data. Other problem is missing data. So here on the left, you are looking at 1 month of the tracking data over the duration of that when that wildfire happened. So there are cells, and this data set is from Mapbox, so it's cell-based, 100 by 100 meter. There are areas that we see a lot of activities, and there are areas that we don't see activities. And these are correlated by highways, on highways and roads. But then the question is, in places that we do not see activity, is there missing data or is there no activity, right? So that's the question. And also, like, if we reduce the timeline, just consider only the cells that we had at least 7 days, then the data becomes nothing. So we need to be mindful about missing data and maybe create new tools and new data integration plans to use other source of data to inform our data set, or utilize auxiliary data to basically model the population that we don't see in the data. Another issue, again, is disparity and the disagreement of the different sources of data. Here in this study, we looked at 9 different sources of data that was shared during the COVID-19 pandemic. And then we looked at the clusters of basically hotspots and cold spots in terms of data, shelter-in-place data, and also mobility indices. So we are looking at 2 different indicators from 2 different sources, shelter in place and mobility index. And then one is from Cubic, which was a licensed data set. You had to pay for it to get the data. And one is from SafeGraph, that was a free source that was shared throughout COVID-19 to understand mobility responses to COVID. So we are comparing these two. As you can see, there is a general agreement. However, if you zoom in and look at different areas, there is this, some areas don't show clusters where the other data set shows more cluster. And also sometimes we see a hot spot somewhere, which is a cold spot in the other data set. So we do not know which data set actually gives a better picture, or at least you need to be mindful about these issues in the data. And when COVID happened, a lot of studies just use one sources of data to model the impact of COVID, to model the spread of COVID, and that would be a major problem. So in a workshop that we are organizing soon in Zurich in June, we are exploring these problems, different types of problems that come with big data to understand mobility and mobility impact and mobility responses. So I welcome you. If you're interested, please let me know. If you're in Zurich or nearby, we would love to have you. And the workshop is sponsored by the Collegium Helveticum and University of Zurich Digital Society Initiative. So please let me know if you're interested. And finally, to end on a better note, we are partnering with Esri at the UC Santa Barbara, the Center for Spatial Sciences, the Spatial Center. We are looking at how we can improve how we teach student GI science. And as I showed, we have a lot of issues with data, but also we have a lot of important spatial problems that we can solve and we can contribute, especially towards the contributing to sustainable development goals and also solving societal and environmental challenges. So we are trying to rethink how we teach GI science to make it more problem-based and question-based, and by linking it to fundamental concept and using more web-based GIS platforms that we can reach a lot of students and a lot of people and advance their skills in GIS. So please let me know if you're interested in this effort, if you would like to contribute. And finally, I would like to thank you for your time and for being here. And also I wanted to thank my group who contributed to this research. And without them, I would not be able to speak here.